we built Gemini from the ground up to be natively multimodal, including something quite important for both of us, programming code. Gemini is able to consistently understand, explain, and generate code that is correct and well-written in most programming languages. That includes Python, Java, C++, and Go. It substantially improves coding abilities over previous PaLM 2 models. From a benchmark around 200 programming functions in Python, it consistently solves about 75% of them in the first try, versus around 45% on PaLM 2. If you allow Gemini to check and repair its own answers, this number jumps to over 90%, which is a huge step forward. It can help you create and prototype new ideas in seconds. Let's give it a try. I really like trains. And if I wanted to create a train spotting location web app, I can simply ask and get a working prototype in less than a minute. While the code isn't perfect, it's really helpful to have a first draft. Gemini on its own has the ability to transform software development as we understand it, but it can also be deployed as a key component of more sophisticated systems.
Gemini is great at coding, but we've been able to take it even further, creating a specialized version that performs remarkably well at competitive programming. Now, why do we care about competitive programming? Well, it is one of the ultimate litmus tests of algorithmic coding abilities. So you have thousands of talented programmers from all over the world that come together to compete and try to solve incredibly complex problems that require not only coding, but also math and reasoning. 2 years ago, we presented AlphaCode, and it was the first AI system that could compete roughly at the level of the average human competitor. Today, I'm delighted to introduce AlphaCode 2, a new and enhanced system with massively improved performance, powered by Gemini. When we evaluate AlphaCode 2 on the same platform as the original AlphaCode, we solve almost twice as many problems. While AlphaCode broke through the top half of human competitors, on average, we estimate that AlphaCode 2 performs better than 85% of competition participants. Let's have a look at our model in action on one of the hardest problems that we faced. And I say hard because in the original contest, in which the problem appeared, less than 0.2% of participants actually solved it. The problem is quite difficult, it's very abstract, so I can't get into too many details, but the basic gist of it is that we are tasked with computing aggregate statistics that account for what appears to be an impossibly large amount of random arrays. The really cool thing is that to solve it, AlphaCode 2 makes use of dynamic programming. Dynamic programming is an advanced algorithmic technique which basically simplifies a complicated problem by breaking it down into easier subproblems again and again. And what's really impressive is that not only AlphaCode 2 knows how to properly implement this strategy, but also when and where to use it. What the example shows us is that competitive programming is not just about implementation. It's also about understanding, maths, computer science, and indeed coding. And that makes it an extremely hard reasoning task. So it's not very surprising that up till now, generally available large language models have scored very poorly on this benchmark. These models are really, really good at following instructions, but AlphaCode needs to do more than that. It needs to show some level of understanding, some level of reasoning, designing of code solutions before it can actually get to the actual implementation to solve the problem. And it does all that on problems that it's never seen before. Another thing that is great about AlphaCode is that it performs even better when it collaborates with human coders who can provide grounding. Basically, developers can specify properties that the code samples have to obey. And when we do that, we see performance increase significantly. We think of this kind of interaction between programmers and AIs as the future of programming, where coders will not just give instructions, but actually collaborate with highly capable AI models that can reason about their problems, that can propose code designs, and that can even help with the actual implementation. AlphaCode 2 was built for competitive programming, but we're already working on bringing some of its unique capabilities right into the general Gemini models as a first step towards making this new programming paradigm available for everyone.